Hello, today is January 15th, 2015, Geometry 6-5 notes, trapezoids, and kites. I will go through the examples with you slowly, but this is some of the vocabulary for these last couple of figures. So the properties of a trapezoid are that the bases are parallel. The bases are going to be the parallel sides. Consecutive lower base angles are supplementary to upper base angles. So last semester you called these same side interior. In a parallelogram you called them consecutive angles. But in a parallelogram they're all supplementary and consecutive because you had two pairs of parallel sides. So just understand that in a trapezoid there's only one pair of parallel sides. So you're only going to have one pair of consecutive angles on each interior. If it's an isosceles trapezoid, then the two legs are congruent, the bases are still parallel, the diagonals are congruent, lower base angles and upper base angles are congruent, and any lower base angle is supplementary to its upper base angle. So a trapezoid, and clearly no relationship with diagonals here, and an isosceles trapezoid. Okay, now a kite is very unique. A kite has two pairs of consecutive sides congruent. Okay, so most of you have flown a kite, hopefully at some point in your careers. So the two pairs of consecutive sides are congruent. They're not all congruent to each other like a rhombus. These two are congruent, these two are congruent. Diagonals are perpendicular, however, similar to a rhombus. A kite has one pair of opposite sides congruent, and the pair that's congruent are going to be the angles where the non-congruent sides meet. So meaning this side and this long guy, these two are non-congruent, so where those two meet, these are the congruent angles. And then what's unique about the angles joining the two congruent sides is that they are bisected. Okay, I'm going to pause there for a minute while I get my examples going, and you can finish jotting that down. Okay, so I am going to unpause and do a couple examples. Okay, each trapezoid is isosceles. Find the measure of each angle. I'll scoot up here so you don't see quite so much of my hand having to move. Okay, so if this is 77, its supplement is going to be 103. Angle 1 and angle 2 are congruent, so that will be 103. And these guys are also same side interior, so that will be 77. Or, since it is isosceles trapezoid, these are parallel, these are congruent. These are the base angles that are congruent. So always more than one way to do things. Over here, here's my legs, here's my bases. 49 degrees is congruent to angle 2, and these guys are supplementary. So 131 and 131. Pause again while I flip this page over so I don't make you dizzy. Okay, so I'm on the other side here. To shrink this up, you're not going to be able to see this, and then it'll be all for naught. Okay, find the measure of the numbered angles in each kite. So this is 90 degrees, no brainer. And if this is 22, this is 22, and the sum of the angles in a triangle, sum is 180. So this is 68 degrees. This is a kite, so angle 1 is going to be congruent to angle 2. So if the sum of the angles in a quadrilateral is 360, 360 minus 54 minus 90 divided by 2 is going to be 108. So I'll just write that here. And they're divided by 2 because this is congruent to this. Okay, find the value of the variable in each isosceles trapezoid or kite. So I will scoot this up so you can see them all at once. Diagonals are congruent, so I'm going to set 3x plus 3 equal to x plus 5. Now here it's just asking for the value of the variable. Make sure on a test or a quiz or the ACT that you read the question and make sure that you answer it. So I knew this because diagonals are congruent. Base angles here are congruent. So I will set 3x plus 15 equal to 60. Okay. This is a right angle, so that's another 3y plus 30 equals 90. 3y equals 60, so y equals 20. I was going to say it's another no-brainer, but that's not very nice, but this is good stuff. All right, this is 90, so that tells me that x plus 6 plus 2x is equal to 90. I could do x plus 6 plus 2x plus 90 equals 180, but that would get you right back to here. I'm off the video. Come on now. All right, 3x plus 6 equals 90. 3x equals 84. Let's see, it goes in there 28 times. There we go. All right, so I will get all of that in the green. I don't know if it'll all fit. There we go. So I'll let that marinate for a minute while I pause and get my mid-segment. So this next concept we had a little bit of last semester. There we go. Okay. So the definition of midpoint is the segment connecting the midpoints on the legs of a trapezoid. And this length is equal to half the sum of the bases. So here's base 1, base 2. Half the sum. So think of it as an average. 1/2 B1 plus B2 equals the mid-segment. Okay. Very popular concept, especially in Chapter 8 when we cover similarity. Lots of concepts there with similarity. All right, continuing. I don't want to make it too dizzy with all my flipping, so I'm pausing and rearranging here. Find the length of the segment length of this mid-segment. I know it's a mid-segment because the midpoint. So this mid-segment is equal to, oh, I guess they called it EF. EF is equal to 1/2 the sum of the bases. So 1/2 of 20 is 10. Find JI. Again, this is a mid-segment. Gonna make you all dizzy. So this is 1/2 x plus 5 plus 4x minus 5 equals the mid-segment, 3x minus 7. So 1/2, 1x plus 4x is 5x, and the 5's are going to cancel. Equals 3x minus 7. Sorry, not a lot of real estate here. So you always have a choice. I like to wipe out my fraction. So I'm going to multiply everything by 2 to get rid of that fraction. In trigonometry, I call it a wipeout. But you have to make sure you distribute it to the other side. So I've got x equals 14. And be careful you're not done, because we're looking for ji. So ji was 3x minus 7. So ji is 3 times 14 minus 7. 42 minus 7 is 35. I'm just going to cheat and do this. Okay. Refer to your textbook. Pause the video as needed. Homework tonight is section 6.5 worksheet, which is the immediately following pages, and I will see you tomorrow.